Let's work with a function and a function block in a ladder program. To add a function to our logic, we select a valid location and press F10. In the name area, we can type move, and it brings up the many different types of move functions. We can see that there are move functions for arrays, bytes, dints, etc. We will select the general move function that works with any data type and click OK. A new move function is added at the location we had highlighted, and we can see that it has an EN and IN input, as well as an ENO and OUT output. If we put our cursor over the function, it will show us the data type requirements for the EN and ENO are Boolean. Let's use Boolean variables we have previously created and move the Boolean variable value of test5 into test6. We will use test7 as the trigger for the function and test8 as the function enable output. When we added the function, the software automatically added a ladder rung to the EN input. We can put a normally open contact on this rung in front of this EN input and select test7 as the variable for the contact. If we press Escape to return to arrow mode in the software, we can double-click to the right of ENO and select test8 as the enable output of the function. Since we want to move test5 into test6, we can add those to the IN and OUT positions of the function. If we download this to the CPU and place it into run mode and monitor mode, we can set test5 to true, and test6 remains false. If we make test7 true to enable the move function, we see that the test5 state has been moved into test6, and test8 became true, indicating that the function was enabled. If we make test7 false, we see test8 go false as well. We can then make test5 false without influencing the state of test6, as the move function is no longer enabled. Function blocks will act very similarly. For our example, let's add a TMR function block. Function blocks require an instance variable to be used. Let's name our instance testTimer1. When we select OK, it will ask us to select a variable for the function block memory. We don't currently have a timer variable, so let's just use testTimer1 var. When we hit OK again, it will automatically prepare a TMR variable called testTimer1 var for us, and if we select OK to create the variable, it will be assigned to the testTimer1 function block instance. If we then double-click next to each input and output of the function block, we can either select a pre-made variable of the correct data type, or we can create input and output variables for this function block. Let's create a normally open contact on the IN rung of the function block and list a local variable called testTimer1 enable. Since this variable does not exist, the software will pre-populate the variable add window with the correct data type and information. We can click OK and it will create the variable and assign it to the normally open contact. We can perform the same workflow to create the other variables, and we can see as we name a variable that doesn't currently exist, the software automatically populates the variable add window with the correct data type. This is a great time saver to prevent us from having to manually select the correct data type every time we want to create a new variable. Now that we have added the variables to the function block inputs and outputs, let's download the project to the CPU and go into Run and Monitor modes. We see the block is disabled and the preset is at 0 currently. If we double-click on the preset, it will allow us to enter a preset time. We will select 5 seconds. If we now make testTimer1 enable true, we see that the timer starts timing, and after 5 seconds has elapsed, the testTimer1 output variable becomes true, indicating the timer has completed. Both functions and function blocks are easy to work with in XG5000. Anytime we have any questions about what the purpose is for a specific function or function block, the help files are always available to give us background information on any one of them.